Every monsoon season, India loses $12 billion to flood-destroyed highways. 400,000 kilometers of road erased. The question is, what if the solution was growing on a tree? India produces 62 billion coconuts annually. The husks, discarded as waste, contain a fiber stronger than steel in tensile-to-weight ratio. Engineers noticed. Join QuitTech Process as we uncover the secrets behind this engineering marvel. The road built from fruit waste, engineered to outlast the monsoon itself. India's National Highways Authority manages 6.3 million kilometers of road infrastructure. Every June, the southwest monsoon arrives and begins its systematic destruction of what engineers built. Conventional bituminous roads fail catastrophically when subgrades become waterlogged. The bearing capacity collapses to near zero. A fully loaded freight truck triggers complete structural failure. Kerala alone reports 4,000 kilometers of road damage annually during monsoon season, an infrastructure emergency that repeats without fail every single year for 4 months. Post-monsoon repair campaigns cost India's Public Works Department 2.4 billion rupees per state per year, rebuilding the same roads with the same materials, expecting different results. The fundamental problem: Kerala's coastal subgrade, black cotton soil and laterite clay, has a California bearing ratio of less than 2 when saturated. That is structurally equivalent to wet sand. Meanwhile, India's coconut processing industry generates 5.5 million tons of coir husk waste annually, a disposal problem of equal scale to the road construction crisis it would eventually solve. The Central Road Research Institute, New Delhi, spent 11 years testing natural fiber alternatives. The breakthrough came from an unlikely source: the discarded husks of India's most abundant fruit crop. Coir fiber, extracted from coconut husk, has a tensile strength of 175 megapascals and a Young's modulus of 4 to 6 gigapascals, numbers that made CRRI engineers stop and recalculate. In 2004, Kerala's Public Works Department constructed India's first coir geotextile road in Alappuzha, 10 kilometers of highway on soft subgrade, reinforced entirely with woven coconut fiber mats. After 3 consecutive monsoon seasons, the coir reinforced test section showed 0 subgrade failure. The conventional road alongside it had been rebuilt twice. The data was unambiguous. The Ministry of Road Transport and Highways approved a national coir geotextile deployment program across 8 states, targeting 25,000 kilometers of national highway sections by 2030. The Coconut Road program is not an experiment. It is a nationally mandated engineering transformation, the largest deployment of biofiber infrastructure reinforcement in human history. India's GDP loses 0.5% annually to poor road connectivity. That is $12 billion evaporating from the economy before a single monsoon flood event is counted. When a national highway closes during monsoon, the ripple effect is immediate. Vegetable prices in isolated districts spike 300% within 48 hours. Medical emergencies become death sentences. The Coir Road program creates a dual economic benefit. It solves the infrastructure crisis while absorbing 1.2 million tons of agricultural waste annually, directly employing 180,000 coir industry workers. A single coir geotextile mat, 4 meters wide, 50 meters long, woven to 900 grams per square meter density, costs 40% less than its synthetic polymer equivalent and biodegrades harmlessly after 10 years. Life cycle cost analysis confirms coir reinforced subgrade construction costs 18% more upfront, but reduces total 20-year maintenance expenditure by 47% on monsoon-vulnerable corridors. In Kerala's 2018 catastrophic floods, the worst in 100 years, coir reinforced roads maintained structural integrity in 94% of tested sections. Emergency services reached flood victims unreachable by conventional road corridors. The World Bank estimates 2.1 billion people in tropical nations live on roads that fail annually during monsoon. Kerala's Coir solution addresses every one of those situations with locally available agricultural waste. Every kilometer of coir reinforced highway generates 40% more local employment than conventional construction, drawing workers directly from the coconut farming communities that produce the raw fiber. NHAI data confirms freight transit time on rehabilitated coir corridors drops 35%. Vehicle operating costs fall by 28%. The road pays for its own premium construction cost within 4 monsoon seasons. In the Sundarbans Delta, where subgrade CBR values measure below 1 and the ground itself is semi-liquid, Coir geotextile road construction is not an enhancement. It is the only construction method that physically works. Kerala's circular economy model is now a textbook case. Agricultural waste becomes construction material. Waste disposal costs become construction savings, and farmers become infrastructure supply chain partners. Districts that received Coir reinforced highway upgrades report a 22% increase in agricultural market access and a 31% reduction in post-harvest losses. The road does not just survive the monsoon, it transforms the economy around it. The coconut palm, Cocos nucifera, produces a husk comprising 75% coir fiber by weight. That fiber grows in a cellular structure that engineers describe as a natural composite material, optimized over 60 million years of evolution. CRRI testing confirmed coir fiber resists tensile loads of 175 megapascals before failure. Its lignin content of 46% makes it 5 times more rot-resistant than jute, lasting 8 to 10 years in tropical soil before biodegradation. The woven coir geotextile is an engineered product, not a craft material. Warp and weft spacing is specified to achieve 40 liters per second per square meter hydraulic conductivity, allowing pore pressure dissipation while providing tensile reinforcement. Each 50-meter coir geotextile roll, woven at 900 grams per square meter, provides 200 square meters of subgrade reinforcement. A 10-kilometer road section consumes 500 rolls. That is 25,000 square meters of woven coconut fiber. Field plate bearing tests on coir reinforced subgrade show a 280% improvement in bearing capacity ratio, a subgrade CBR of 2 performing as a CBR 7.6 under equivalent load, the fiber mat distributing stress across a 3-meter influence zone. The coir mat's open weave structure provides 40 liters per second per square meter of lateral drainage capacity, actively removing pore water pressure from the subgrade during heavy rainfall, preventing the saturation that triggers conventional road failure. The Coir geotextile's 10-year biodegradation timeline is a feature, not a flaw. As the fiber degrades, it deposits organic matter into the subgrade, permanently improving its structure and drainage characteristics, a self-replacing reinforcement system. The mechanism is elegant. The coir mat's tensile strength, 175 megapascals, resists the lateral spread of the subgrade under vertical load, transforming a locally concentrated stress into a distributed pressure the weak soil can resist. Every coir geotextile roll is tested to IS 14715 standards before delivery. Minimum tensile strength 8 kilonewtons per meter in both directions. CBR puncture resistance minimum 0.8 kilonewtons. Hydraulic conductivity within specified band. The retting process, soaking husks in Kerala's backwater lagoons for 6 to 12 months, softens the pectin-binding fiber bundles, enabling extraction of 20 to 30 centimeter long filaments with the lignin content preserved. Ancient process, modern engineering application. Advanced formulations blend coir fiber with high-tenacity polypropylene yarns, creating hybrid geotextiles with tensile strength exceeding 25 kilonewtons per meter, targeting the most severe soft ground applications where pure coir approaches the limits of its tensile capacity. Embedded subgrade sensors on monitored coir road sections confirm pore water pressure peaks 65% lower than conventional sections during equivalent rainfall events. The coconut fiber is actively managing the water that would otherwise destroy the road. Construction begins not with machinery, but with measurement. Every coir road project requires a full subgrade characterization, CBR testing at 100-meter intervals, moisture content profiling to 1.5-meter depth, plasticity index determination of the native soil. Soft subgrade preparation, excavation to formation level at 600 mm depth using a fleet of hydraulic excavators, exposing the native soil. Where CBR is below 2, lime stabilization at 4% by weight is applied before coir mat placement. The prepared formation must achieve a 3% crossfall, critical for directing surface water toward the road edge drainage channels before any coir mat can be placed. Flatness tolerance, plus or minus 15 millimeters over a 3-meter straight edge. Logistics. A 10-kilometer coir road section requires 500 rolls of woven geotextile, 25,000 square meters of coir mat. Delivery is staged to maintain a 48-hour buffer ahead of the installation front, protecting against supply disruption.
Installation protocol: Coir mats are unrolled perpendicular to the road axis at 300 mm overlap joints, secured with U-shaped bamboo pins at 1 meter spacing. The entire subgrade surface must be covered before any fill material is placed. For soft subgrade values below 1, the Sunderbond's delta condition, a double-layer Coir reinforcement system is specified. 2 mats at 200 mm vertical separation within the granular fill, creating a tensile reinforcement zone 400 mm deep. Granular fill placement over the Coir mat is done in maximum 150 mm compacted lifts using light compaction equipment only, vibratory plate compactors and pedestrian rollers, to prevent displacing or distorting the installed geotextile. Compaction energy is controlled precisely. Light vibratory plate compactors at 18 kilonewtons per square meter dynamic compaction force, achieving 95% modified Proctor density in the granular base while protecting the Coir mat structure below. Once 600 mm of compacted granular fill covers the Coir mat, full-weight vibratory roller compaction commences. Caterpillar CS series rollers at 10 tons static weight, achieving the full sub-base density specified for Indian National Highway construction. Above the Coir reinforced subgrade, construction follows standard MORTH specifications: 250 mm granular subbase, 250 mm wet mix macadam, and 100 mm dense bituminous macadam, the same upper structure as any national highway, now on a monsoon-proof foundation. The final wearing course, 40 mm dense graded bituminous macadam, placed by a fleet of Vogel Super 180 pavers at 160 degrees Celsius, compacted to 98% Marshall density, the conventional surface over the unconventional foundation. The drainage system is integral to the Coir road design. Longitudinal drainage channels at both road edges, sized for the 50-year flood event discharge, receive the lateral drainage flow from the Coir mat layer and convey it to natural watercourses. Cross-drainage structures are designed for the 100-year return period flood event. Precast box culverts with 2-meter internal dimensions installed at every natural drainage line ensure the road never becomes a dam that backs up monsoon floodwater. Kerala's backwater crossings represent the most sensitive construction environments. Coir geotextile maintains its structural function fully submerged, a critical advantage in the backwater crossings where conventional geosynthetics require dewatering protocols. Quality assurance follows IRC SP 89 standards, field CBR testing at every 500-meter interval, density measurement at every compacted lift, bituminous mix verification every 400 tons, the scientific rigor of laboratory testing applied in real time to active construction. Completion: a 10-kilometer Coir reinforced national highway from subgrade preparation to final wearing course takes 90 days under peak production conditions, comparable to conventional construction, with 47% better monsoon performance. The first monsoon test, 350 millimeters in 24 hours, the standard Kerala heavy rainfall event. The Coir road drains without distress. Surface water clears within 8 minutes of rainfall cessation. The subgrade sensor data shows pore pressure, nominal. Deflection under load within design limits. The road holds. The most powerful evidence: side-by-side performance during the same storm event. The conventional road section, 200 meters from the Coir section, registers complete subgrade failure at 180 millimeters of rainfall. The Coir section continues carrying full traffic. Post-monsoon deflection testing using the Benkelman beam confirms Coir reinforced sections show residual deflection 40% lower than pre-monsoon baseline. The subgrade is actually stronger after the monsoon than before. The Coir mat functioned precisely as designed. The 2021 Konkan floods, 600 millimeters in 24 hours, a 500-year event, submerged the surrounding landscape with 3 meters of water. The Coir reinforced section of NH66, fully submerged for 72 hours, emerged structurally intact. No subgrade failure, no pavement displacement. Emergency repairs on conventional roads destroyed in the same flood cost 890 million rupees across 240 kilometers. Equivalent length Coir reinforced sections, 0 repair cost. The performance differential is no longer a laboratory result, it is a budget line item. 10-year performance data from Kerala's first generation of Coir roads confirm design predictions. International roughness index below 3.5 meters per kilometer. Structural deflection within design limits. The roads built on coconut fiber are outlasting every engineering projection. After 10 years, Coir geotextile extracted from
The original Alappuzha pilot project shows 70% biodegradation, and the surrounding soil has transformed. Organic content up 180%, permeability improved 340%. The fiber gave its structural service, then became soil amendment. Kerala's Coir road network, 3,400 kilometers completed, 47 monsoon seasons survived across the full network, 12 billion rupees in avoided repair costs, and counting. The coconut has stopped the monsoon from eating India's roads. Bangladesh, 170 million people, 22,000 kilometers of monsoon-vulnerable roads, and the world's largest jute industry, a natural fiber even stronger than coir. The technology transfer from Kerala is not hypothetical, it is already in pilot stage. Vietnam's Mekong Delta Connectivity Program has adopted Coir geotextile road reinforcement from India's IRC SP89 standard, deploying the methodology across 800 kilometers of Delta Highway through a landscape where the engineering challenge is identical to Kerala. Nigeria's Niger Delta produces 1.8 million tons of coconut waste annually, discarded. Its highway network loses 30% of paved roads to annual flooding. The solution is growing in the same region as the problem. The connection has not yet been made. It will be. Next-generation research at IIT Madras focuses on Coir carbon fiber composite geotextiles, 400 megapascal tensile strength, 25 years service life, targeting the most severe soft ground highway applications where conventional coir approaches its performance boundary. Mechanized mat installation systems under development at CRRI can deploy Coir geotextile at 2,000 square meters per hour, 4 times the manual installation rate, using purpose-built roll-laying vehicles that unroll, position, and anchor the mat in a single continuous operation. The Coir road program carries a climate dividend. Every ton of Coir geotextile used in road construction replaces 0.8 tons of polypropylene synthetic alternative, avoiding 2.4 tons of carbon dioxide equivalent emissions, while sequestering 1.6 tons of biogenic carbon in the soil. The full circular economy. Kerala's 90 million coconut palms produce fiber. Fiber becomes geotextile. Geotextile becomes highway foundation. Foundation becomes 10 years of monsoon-proof road. Road biodegrades into soil improvement. Palms grow better, more fiber. The cycle continues. The World Bank's 2023 infrastructure report cites the Kerala Coir road program as the leading example of biomaterial road reinforcement globally, recommending its adoption across 23 tropical developing nations with compatible agro-industrial waste streams. Every inauguration of a Coir-reinforced national highway represents 3 simultaneous achievements: flood-resistant infrastructure for 30 years, dignified employment for Coir workers for a decade, and the elimination of a waste disposal problem the size of a small mountain. By 2030, India's National Coir Road Program targets 25,000 kilometers of monsoon-reinforced national highway across 8 states, an infrastructure transformation the size of a continent built on the fiber of 62 billion coconuts. The monsoon comes every year. It always has. It always will. But now, beneath the roads of Kerala, 1 billion woven coconut fibers hold the earth in place, and the road stays open. Ancient material, modern engineering, permanent solution. For more engineering marvels that are reshaping our world, subscribe to QuitTech Process. The secrets of extraordinary construction are waiting. We will uncover them together.